J.
I got J.
Oh.
Alright guys, let's do the first three passages of 73C, science. Okay, so who can explain number 1? Yeah, Rithik.
Okay, so number 1 is so in figure 2.
So what am I going to underline in the question?
Question on the brightest or average.
Okay, so you weren't here when we covered how to approach science. So what you do is you look for indicators. How the indicators are figure 2, figure 1, figure 2 right here. It's which picture to look at. So we need to underline that, and then what's the question itself that they're asking.
Alright, figure 2 you need to underline.
Good.
And brightest surface. So
That's it. Good.
Yeah.
Alright, so how do I do this now?
Alright, so this graph in figure 2 is already the average. It's the average. So you just have to pick the highest point, which would be 0, which is at around 75.
Good. How do I know it's 0 and not 50 or 100?
Because it's the highest.
Well, just because it's the highest, what does that mean?
It means
We have to always read our axes. What does relative reflectance mean?
it's
When something's bright, this goes, what?
It's how bright.
Yeah. So whenever your eyes see colors, it's measuring the light that's bouncing back. So the more light that's reflected, the brighter it is. Okay? That's the whole basis of this pass. So yep, it is at the coastal site. Another way to cross out, if you think it shouldn't be 75 and it should be 0, the two answer choices were 50 and 100. At 50 kilometers, it's 0, right? And at 100 kilometers, it's almost 0 as well. So it can't be either one of those answers because it gives us the same thing. So 50 and 100 are both crossed out. At 150, it's like 7. It's like 10. Okay? All right, number 2. Who can do that? What do we underline? Manvita.
Underline figure 1, and then underline dorsal stripe, and then 0.25 and inland distance. Actually, you don't need that.
Okay.
And then you look at figure 1, and then you go to the dorsal stripe graph, and when you go to 0.25, it hits the line at about 60.
Good. So I'm just going to follow that down right here. If I go up 0.25, draw that right over to my line. That's around 60. Good. And which answer choice is that? That's H. All right, next one. Venkat.
You underline figure 1, greatest change, rostrum, and yeah. So you go to figure 1, and then you go to the rostrum graph, and it shows you the greatest changes between 50 kilometers and 100. So you choose 50 and 75 since that's like the
Good. This entire piece right here represents our greatest change because it's the steepest slope. Okay? And that is C. All right, next one. 4. Who wants to do it? Varun. 4.
You underline figure 1, and then lighter or darker.
Okay, and then what else do I need to underline?
Average.
Nope. What's my other? Yep, Rithik.
Ventrum.
Good. What else?
150.
Perfect. All right. Figure 1, Ventrum, 150. And what else? Coastal site, because I'm comparing 150 to coastal site. So let's go to figure 1. Ventrum. We'll compare 150 to coastal site. Okay, what's at 150? And what's at coastal? So, who can tell me? Yeah, Rithik.
So at 150, it's 0, and at coastal, it's 1. So I put J.
Okay, good. Something you need to notice about these questions, there's always 2 parts. Manvita, Venkat, you guys have got to stop talking, okay? There's 2 parts to these types of questions, okay? You have the first part, which is always lighter, darker, and darker, okay? The second part is, who can tell me what the second different word is?
Reason.
Nope.
Isn't it greater and less?
Yes, greater, less, or yeah, you get it, less, greater. Okay, so there are just 2 parts to this. The rest of the stuff is the exact same. So we can which answer choices can we automatically eliminate?
F and G.
F and G. We can also do F and G or F and H. Under the Y, F, and G.
Because it says lighter. And
Good.
that's darker.
Yep, so it wouldn't be lighter, it would be darker. And then we go and find a difference. Yes. Or you can go to Amitabh side and look at the ending, which is the greater part. So the F and H can be canceled out. All right, 5. What can we underline?
Um,
Or who wants to do 5? Venkat, do 5.
Okay. So you can underline P poly. Actually, I don't think you need to underline that, but at any given inland distance, and more closely, and mouse matches the soil. I got B, and I didn't really find where to show it in the passage.
Okay, this one is what we call, remember, there are always 2 to 3 prior knowledge questions. This is where if you paid attention in science class for the past 7 years, you'd know this question. It's pretty basic. It's just the difference between a predator and a prey. Okay, what is a predator? It's the big animals that eat the small ones, which are the prey. All right, so if it blends in, it's going to be less likely to be found. And then natural selection says that the favorable traits get passed down. Okay, which this would be a favorable trait, which is going to be passed down. All right, 6. Who wants to do it? Yeah, Rohit.
So I underline figure 2, and then coastal site, lighter and darker, and then the standard. And then I got J because the standard was 100%, and at the coastal it was only near 75%.
Good. This is the one where you also need to know that another way to do it is whenever you have an asterisk, you always read what's down here. This section you should have all read. What does it say? It says, the darkest was assigned a value of 0. The lightest was assigned a value of 1.
Isn't that figure 1?
Yeah, this is also for figure 1, but you need to know that idea of the relative brightness, that relative reflectance. Actually,
I used
One from figure 2.
Yeah.
yeah, but you need to know that the less percentage that's reflected means it's darker.
Oh,
That prior knowledge, because that's the only way to answer this question. This is a prior knowledge question. Also, you could have figured it out from this little section right here. Okay? But yeah, it is J. Does everyone get it? All right, let's go on 7. What type of experiment is this? Can someone sum up what they're doing right here?
it's chemical.
Yeah, so what are they doing? Which 2 chemicals are they mixing?
Hydroxide, nickel.
Yes.
Hydroxide,
Okay, yep, they're just mixing hydroxide, which is OH, with nickel. Okay, then they're passing it through filter paper, and then they're seeing what comes out, and they're measuring that. That is our CNF. Okay, so how do I do 7?
you just look at that table.
So tell me what I'm going to underline, Venkat.
2 days, in experiment 1,
What else?
CNF.
All right, good.
So you look at table 1 and CNF in table 1, and you look at the reaction time of 2 days, and you see that the day between 1 and 2, it's 6 and 39. So, my bad. So the reaction time, it says 10 minutes and 3 days. So in the middle, that would be 2 days, I guess. And since the CNF is 6 and the other one is 39, you would do between.
Good. All right. Ritik, you got a question?
No, I was going to ask her to do number 8.
Okay, yep, you can do it. Let's go over this. So yeah, so with 2 days, you just look in between 10 minutes and 3 days, and you get between 6 and 39. All right, so our answer should be B. All right, Ritik, do 8.
So you underline experiment 1 and experiment 2 results of, and you also underline lowest concentration of dissolved nickel in the filtrate and combination of reaction time and filtration.
Okay.
And so my answer was F table 1, so it's asking for the lowest concentration, and in table 1, experiment trial 1 for 10 minutes, it was the result was 6, which is the lowest for the filtration method. So
Okay, so how do I? So you got me my 10 minutes versus 7 days because here it obviously shows that 10 minutes for both of them is less than 7 days. Okay, so that's good. We got rid of which answer choices do we get rid of?
G and J.
Yep, G and J are eliminated now. Okay, how do I differentiate between F and H?
the filtration method.
Okay, how do I know which is experiment 1 what?
Experiment
One
one
is
standard.
Okay, where does it say that?
Below the trial, step
Under the
Step 3, standard filtration. What does it say for experiment 2?
that he uses vacuum.
Yes, right here, vacuum filtration. Another way to see is just look at the picture right here. It's connected to a vacuum pump, okay? And right here there is no vacuum pump, so it is obviously going to be 10 minutes for a standard filtration, which would give us our lowest CNF. All right, 9. Who can do this one? We're in number 9.
You underline net force. More likely greater in trial 3 and trial 6.
All right, remember this. It's the exact same form. The first word is different, and then there's going to be always one more word that's different. Which one is that?
Was connected.
Yes. So it's either was connected or was not, and that's the exact same in all of them. Yep, that's it. All right. So Varun, what's the answer for this one?
C.
Okay, how'd you get that?
Because like the CNF is more like for trial 6, so like they must use like the vacuum pump.
Okay, but they also say right here they explicitly said they use vacuum filtration, right?
Yeah.
Okay, so we don't even need to look at the CNF, and that's good that you figured that out as well. But it says vacuum filtration right here, so in experiment 2 used vacuum filtration. So comparing trial 3 versus trial 6, what's the difference? What did they use in trial 3?
They did use it.
Yes, they use standard filtration. Trial 6, they use vacuum filtration. What happens when you put a vacuum on something?
It sucks.
Yeah, it sucks it harder. Okay, so that's why the force is going to be greater. So we can automatically eliminate A and B. So what's the difference between C and D now?
One was
Connected or not?
Okay, trial 6. Was it connected to a vacuum pump? Yes. So which one can we eliminate?
D.
D. Yes, that's good. So the right answer is C. All right. 10. Rohit.
So you just have to like look at like the steps for this. So like they just like mix the nickel and the OH. Like you can see this in like the experiment 1, like for number 1. And then like they got like the solid material from number 3. You can see that, and then you can see in the number 4. They measured the CNM.
Good. So they first mixed OH and Ni. They stirred it, poured it through here, filtered it out, and collected it. Which that answer choice is closest to G. Okay. 11. Who can do that? I'm Tesh.
So you would underline a greater CNF 3 days.
Before greater CNF, what else do we have to underline?
Vacuum.
We only underline stuff that differentiates between experiment 1 and experiment 2.
Vacuum filtration. A reaction time for 3 days. Then for a reaction time of 10 minutes, and there's the data in table 1. So then you would go to table 1 and see like the 3 days and the trial 5 and trial 4. The CNF for trial 5 is greater than the CNF for trial 4. So the answer would be D.
The answer is D, but explain that all over again.
So you go to table 1. Trial 5 has a CNF of 69. Trial 4 has a CNF of 658. So since 69 is greater than 58, answer is D.
Good. All right. 12. Who can do this? Krisha, can you explain to me how to balance equations first?
If you add something to one side, you have to add it to.
Good. What law does that say? Satisfy? Law of conservation of mass. Okay. Where you have to have equal things on both sides. All right. What was your question during the test that you had, Rithik?
That was for 13.
13? Okay, we'll come back to that one then. Krisha, finish this question up.
So you underline nickel hydroxide monohydrate.
Oh, wait, this is the wrong question we're on. I was thinking, all right, just do 13 first then.
No, you underline balanced chemical equation. Underline 6 OH ions and NiOH2 H2.
Yeah, you can do in the passage. That tells us that we need to look in the intro. Okay, so we're adding 6 OHs. Right now, we only have 2 OHs. So how do I do this question? Rithik, explain to me how I'll do this. So I have 2 OHs. 2 OHs give me 1 Ni right now. But if I want to have 6 OHs, how many Nis do you think I'll get? 3, yes. The easiest way to think about this is, if 2 OHs gives me 1 Ni, how many would 6 OHs give? So I just put that as X. And then I cross multiply, which it would be 3. Okay? Alright, that answers A. Alright, Krisha, can you finish up 12?
Yeah, so you underline nickel hydroxide monohydrate, standard filtration, and then 3 days. Then,
Not just 3 days.
at least.
Yes.
Then when you look at table 1, you see that there was only one child. Wait.
Did you put 1 on your test?
Yeah.
Yep.
The 2.
Yes, 2. Rithik, why is it 2?
Because so it says standard filtration. So in the table 1, you go to experiment 1, which is standard filtration, and it says at least 3 days, which means 3 days and above. So it's 3 days and 7 days. You get 2.
Good. All right. Let's go on to this passage. I hate this one, but let's do it. Who wants to do 14? Yeah. Rohit.
So I understand. I underlined relative to the center of the protostar. Does accelerate gas particles inward or outward, and RP more likely accelerate gas particles inward or outward. And like how I found this was it says in like a passage, gravitational field attracts gas, and then the RP pushes with the protostar's emissions causes gases to be pushed away. So like that, so I got G for that. It's like how I got that.
Okay, so RP we know pushes away the gas. Okay, so that eliminates F, and then which other one? H. All right, we're left with G and J. Where do we find the thing about gravity now?
It says gravitational field attracts gas.
Yes, good. Gravitational field attracts the gas. So attract is our key word, so that means it brings it inward, and that would be G. All right, 15, who can do that? Frank Cat.
I got, underline scientist 2's argument, and gas particles more likely accurate near the equator. Actually, I don't think he did that. But you look at scientist 2's argument, and it says a disk of gas forms in the plane of protostar's equator, this reduces the effective RP in that plane, which means it's near the equator because the RP is reduced there.
Good. So where did he find that? He found it right here.
It's like the second.
Yep. It goes, a disk of gas forms at the equator. This reduces the effect of RP, which should give us B. Make sense, everyone?
Yep.
All right, notice again, this question type, there are two, the first words are the same, equator, equator, poles, poles, then there's something else that's different.
Increase, reduce.
Yep, increased, and then reduced. All right, let's go on to 16. Who can do that? Ruin, 16.
You underline inconsistent.
Inconsistent with what, though? These types of questions, what they try to do is they introduce new information in the first sentence. And then the second sentence is typically the question itself. So what are they telling us in the first sentence?
There's no evidence of stellar mergers.
Good. No evidence of stellar mergers. So who is that inconsistent with? Something you guys should do while you're reading it. Remember, this passage, did we read it?
Yeah.
Yeah, we definitely should have read this one. What?
Yeah, I read it.
You read it? Okay, remember, conflicting hypothesis. This is scientist one, scientist one, student one, hypothesis one. We always read this. What you should be doing as you're reading is you read the first one in depth. The second one, you should skim, and most likely, it just changes one thing. Notice how he says scientist one is correct, but he changed one thing about scientist one. If you guys got questions, make sure to ask me, okay? Don't work together. All right. So while you're doing that, you should automatically be underlining the key things in scientist 1, scientist 2, and scientist 3. So can someone briefly explain what each scientist believes in? Ritik.
Okay, so scientist one believes that that stellar mergers they are like likely because they could start. Wait a second. So scientist one believes that stellar mergers are have occurred, and scientist two agrees with scientist one about stellar mergers are being likely, but scientist three does not agree and thinks that given the vast distances between stars, they're very unlikely.
Okay, now what else is different between all three of these now? Now, so we did that. We did the stellar mergers. Now we have to go with the RP thing. Okay, so are they saying that the effect of RP is uniform in all directions around a protostar? Then scientist 2 says,
Gets reduced.
yeah, it gets reduced and the gas forms at a disk at the equator. Scientist 3 says what?
It increases.
Yes, increases the effect of RP. So we have decrease the effect, nothing about the effect, and then increased effect. And then all the stuff about the stellar merger. So let's go back and look. A detailed survey so you should really have like 3 key things in each thing underlined. And that tells us their stance. So here, I underlined the thing about stellar mergers. Stellar mergers are likely. Stellar mergers are likely. And then stellar mergers are very unlikely. So I underlined those key things in each one. And that should help me answer this next question. Detailed survey of star clusters in and near the Milky Way have yielded no evidence of stellar mergers. Which one is this inconsistent with? Well, who said stellar mergers are likely?
Scientist
1 and 2. Yeah, so this would be very inconsistent with their belief. So it's H. All right, 17. Who can do this? Krishay.
So you underline arguments of scientists 1, 2, and 3. Then minimum number of stars. Then accretion. Then
And what else? What's the mass of Eta?
120.
Good. All right.
Yeah, if you look at scientist 1 argument, said that can reach the maximum. Wait. No. Oh, so instead of it's 20. So which means yeah, and then the question says 120. So if you divide that, it'd be 6.
Good. So which one does that automatically eliminate?
A and B.
Okay.
Now if you look at scientist 2, it's 40. So it has to be 3.
Good.
So it makes D.
Perfect. All right. Our right answer is D. Okay. What this is saying is what each scientist. Another thing you should have done. What's different? This one says 20. This one says 40. And then this one says what? It doesn't say anything. Okay? So, what is this saying? This is saying the maximum star we can have is 20 ms. After that, we need to merge. The stars need to merge. Well, remember he said stellar mergers are unlikely. That's why he doesn't have this number. Okay? Because this one says that after that, we need to merge. Okay. 18. Who can do that? I'm Tish.
In student 1, so underline the effect of RP. Underline support scientist 2's argument and weaken scientist 1's argument. And then you'll go to scientist 1 and scientist 2 in the description, and it says in scientist 1 it says the maximum mass is 20 ms. So the maximum for the scientist 1 is 20 ms, and the maximum for scientist 2 is 40 ms. So it has to be between 20 and 40. So the answer is H.
Good.
30.
So that would support scientist 2, but weaken scientist 1. Because scientist 1 said you can't go over 20. So if we choose a number 30, that's above 20, but that's below 40. All right, 19. Who can do it? Venkat. Actually, Rohit.
So I underlined scientists 2 and 3. And like a disc forms around a protostar. And yeah. So I got 8 for that one.
Okay, how'd you get that?
So it says like here in scientists 2's, it said, however, because a protostar rotates about its axis, a disk of the gas forms in the plane of the protostar's equator, and like that's like motion.
Good. What's the key word that indicates motion?
Rotates.
Good. Rotates. All right. Next one. 20. Let's do it. Varun. Actually, I'm with the 20.
I didn't get to this one yet.
All right, let's try it right now then. Which of the scientists, if any, would likely to agree that the sun could have formed entirely by accretion? So sun entirely by accretion. All right. What is accretion now?
Accretion isn't it like the merging of the stars? Accumulate onto the protostar.
Okay, so how do we
Adding onto the
how do we do this one?
star. Okay. Well,
You don't even need to know the definition of accretion to answer this.
you don't need to know it.
Nope.
So just read through whatever they say.
No, let's think. Okay, so
The
What-
one mass equals, the one ms equals mass of sun.
yes. So when I say 1 ms equals the mass of the sun,
That means there's at least this.
at least there's one sun at least, right?
And then
Here there's at least one sun, and here what is it? That's all you need to know. 1 and 2, right here. If it has to be 1 and 2, so it cannot be. It has to be H, so we know it has to be scientist 3 as well. Okay. All right, 21. Actually, we didn't get that far. Okay. Let's go over it. How long do you think we're going to need to answer the rest of the questions? 4 minutes for the next passage. Next one after that? Yep. And then last one? 3. Okay, let's see. All right, any of them do we need to read passage 4? Well, there's nothing hard about this, right? It's just a few bar graphs. Okay, next one. Passage 5. Is there anything hard about that? Okay, 5. Would we read this? Well,
I would do 5 because of the finger.
Yeah, if you're not a physics guy, read 5. Okay? Ritik, does that make sense? If this is hard for you to understand, some people understand this graph already. If you don't, I would read it.
Okay.
Passage 6. Is there anything hard about that? No, it's just line graphs. There's nothing hard about that. Okay, so if you want, you can read this cathode one, but you don't need to. Okay, so I'm going to give you guys, how long do you guys think I should give you? Add up all these minutes. Yes, 11 minutes. Okay, so you guys have 10 minutes and 30 seconds. You guys can start. Fill out everything on your scan time, okay? I'm gonna give you no extra time. Alright, let me use scantrons. Okay, take another 7 minutes, work with the people around you, and annotate the whole test, okay? Just want to know, whenever you annotate science, remember, just circle where on the chart you found your answer, and just write question whatever number it is, okay? That's how you annotate science. And that's how the homework should look. Alright.
I didn't get two. I got two passion five. But yeah.
I didn't get to the last one.
I didn't even get to the last.
Wait, but for photosynthesis, isn't it carbon?
I guess I have second.
Yeah.
If you got that photosynthesis,
You got that one wrong.
No, I
No,
didn't. I got that right.
I circled this one, but I put.
Alright, wait, what do you get for the
Oh.
photosynthesis one? I'd like
It's
to hear.
D, right?
Let me check.
I circled C for some reason, but I put D.
Let me
Which
find
one?
it.
What is it? 27.
Equation.
I put D somewhere.
Correct, come sit here.
Bro, how did you get C?
I accidentally circled it wrong.
You
I
got
got D though.
Oxygen? Oxygen?
Are you high?
Are you dumb?
I put D.
Yeah, you said you put C.
No, I circled
Okay,
C, but I
relax.
put D.
Oh.
I guess passage 5 and 7.
I D.
Yes.
I was about to start 5, but I saw it was 0, so I'm like, oh, I missed
You didn't even finish 4?
No, I finished 4, but
I did.
it was 1, 0 as soon as I finished. I was like,
I saw 5 and it looked really long, so I was like,
Was that wrong?
Come here.
Was that wrong?
don't get mad at me.
Yeah, we're supposed to
I
be
don't
at
know.
work. You look
I know, like,
Forgot.
Alright, so what do you get for number 28? If that's the first one.
This is
28, I got.
You didn't even do
I
it!
did. 22.
Okay, so
I just
Yeah.
read my answers on here.
you look at.
Oh, really?
Oh, so
What's
the mixtures
20,
go from
33?
0 to 100. So then the mixtures go like up, so then
Huh?
they go
B or
up, down.
D. I put D.
Yeah, I put
Yes.
D too.
I'm just gonna go.
B or D?
D.
Oh, I put D. Because we always do the D.
It might be B.
I did D.
I don't know. It might be D.
Dubs.
These are B.
Sticking balls. Sticking balls. This is my gang sign right here.
oh
Sticking
yeah,
balls.
I did use 2.
Balls.
I didn't feel like
Do I realize that?
Are you serious? I lost both of mine.
Like, at first, I knew that.
Bro, this guy threw a basketball at my thumb and it like shifted. I felt it
Are you getting
shift.
any fun?
No, I'm going to Yusuf's.
You should be like, oh, be fitness.
I was TCC yesterday.
Why did you tell me to come?
Oh
I
yeah.
wasn't gonna come anyway.
Yeah.
I thought it was closed.
No, it's on good now.
Till 10:30.
Oh,
Okay,
I'm not even.
so you underline studying.
Best way to flick someone off.
We need to get this stuff.
Venkat.
Why do you get There's nothing there?
Really? There's nothing there.
There's nothing there.
There's nothing.
Like what?
Leave it for you.
If anything.
Yeah, we're gonna go party.
Do I have toothpaste on this shoe? Fuck.
No, my favorite shorts. I was brushing my teeth. Then Venkat decided. No, I was about to brush my teeth. Then Venkat came over. So I was keeping him out of the house while I was brushing my teeth. And then got on my favorite shirt and my favorite shorts, and they won't come off no matter how much I tried licking them off.
Looking off.
Yeah. So then,
Um,
jeez, what did I do with my pants? On top of my grandmother, she pisses me off. She also pisses Venkat off. Like high key piss off. Alright, what do you get for 29?
wait, why is 22?
22
I
was.
You get G.
I got a B for 22. For 29.
No.
We didn't do 22. We already did that. That smash is 4.
Oh.
Yeah.
Jonas.
Oh, good.
You're
Yeah, we got-
Jonas.
I'm pretty sure it's G. I mean, like, somebody's.
Ooh, that was a lot. Oh. Huh?
Wait, so 28 F, 29. I got B.
29?
Mm-hmm.
What about 30?
30. 29 is C.
No, it's
29
B.
is literally B. Are you
It's
high?
B. What are you high on, bro?
Okay.
Venkat, what are you high on? It's B.
Okay, let me.
What's
Oh,
your
you-
2.6 is
What
between 2.1 and 2.2.
What's bigger?
One.
What's your gonna say?
I got a 94.
Like, what? It's on 30. I got 29.
You got a 29. I got a 27.
Bad.
It's okay. I got an A.
You bigger?
Yeah. I'm literally in your class.
Yeah.
You chill.
You're literally in my class. Alright, what do you get for 30?
30. I didn't do 30.
I got 8.
I keep biting my
Good. G. I got G.
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 Let's get started, guys.
Oh.
Alright.
Trial? Where's trial?
Who wants to do number 21?
I'll do 21.
All right.
I got, well, you underline both studies. Volume of vermicompost and 0 to 100. So you look at figure 1 and figure 2, and you see that it increases and then decreases for both of them. So it's B.
Nope. Who wants to do it again? Who wants to do 21? Your answer's right. Your explanation is not.
Oh, okay.
All right, wonderful.
Okay, so you look at table 1, and when you look at the vermicompost, it goes from 0 to 100 through mixtures 1 through 6. So then you look at mixtures 1 through 6 on both of the graphs, and the bars go up and down for the average yield.
Good. So you need to first see this part right here. This tells us our percentage of vermicompost, which they say as a percent increase from 0 to 100%. You don't know if 0 to 100% is from 6 to 1 or from mixture 1 to 6. So the only way to tell that is by going and looking at this table right here. Okay, next one, 22. Wants to do it? I'm gonna test 22. All right, Varun, 22.
You underline study 1, and then you underline control, and then you got F.
Good. What other possible one could it be? Yeah, it could be either F or it could be either mixture 1 or 6. We don't know. But since mixture 6 is not an option, it has to be mixture 1. Okay, 23. Who wants to do it? Rohit.
So like these underline 71, calculated programs, and average yield for mixture 5. I got B for this one.
Good. And 1 kg,
Is 1,000 grams.
yes, equals 1,000. That's all you really need. This is a prior knowledge question. And once you know 1 kg equals 1,000 grams, you know, you got the answer for this. All right, so it should be B. All right, 24. Who wants to do it? Appreciate 24. What's the easiest way to figure this out? Instead of looking at what's the same, what do we look at?
What's different?
Okay, so what is different?
In study 2, it says that Fox received water and light for 149 days instead of 58. Oh, and then also 5, and then C and C instead of the glycol.
Okay, so our two things they changed were the time and the type of seed, right? Okay, so so in reality, these two experiments cannot be compared. This is not a valid experiment because we're changing two variables. What we call that is a confounding variable. We don't know which one is actually causing the results of the experiment. So which one is it? It's either length or it's either the seed. So which options are there?
Oh, one.
Length. Okay, so it has to be any answer choice without the number 2 is right. So it would be G. Good. All right, 25. Who wants to do it? Again, this type of question, there's always just 1 or 2 things that change. Everything else is the same. Who wants to do it? Krishay.
So you underline lower proportion,
What requires a lower proportion?
the plants.
Which type of plant, though?
Tomatoes.
Good. Tomato plants, lower proportion. Now what else?
And then maximum and pepper.
Good.
And study 1.
All right. So now what do we need to do? We need to figure out which study is tomato, which study is pepper, right?
Yeah.
So how do we do that?
If you look at the top, it says that as like first column is tomato and then capsicum and then the pepper.
Good. Whenever you don't know the definition of something, go to the intro. It's always defined right there. And right here it says capsicum is the pepper, solanum is the tomato. All right. So right here, they say, where is it? They planted this one, this type of seed, the lyso whatever seeds. So what is this? This is our tomato. So that's our T plants. And in this study, what do they say? They planted 5 C annum instead of the lyso. So this one is our pepper. Okay, now what do we now go back to the question, Chris, answer it.
So then it'll be A because if you see in mixture 2 in figure 1, it attained the highest.
Okay.
Then in figure 2, mixture 3 attained the highest. So yeah, if you look at A, it mentions that.
Okay, now how do I compare this back to the proportions?
Oh yeah, it's in table 1.
Good. So which one has a higher proportion?
Mixture 3.
Good. So the right answer is what?
A.
Good. So the greatest was, yep, that's it. Ritik, you got a question?
That was really what I was gonna say.
Alright, do it.
I got J. Because in study 1 and study 2, it says all the seedlings that had emerged were removed from the pots with the exception of a single seedling in each pot.
Good. Right here says exactly what he just said. Underlining shit on this. We're gonna get something better to do this soon. Alright. Yeah, that's it. It's J. That one's an easy one. Alright. Whenever you want to know conditions for the experiment, like the steps they took, always look right in this intro right below the study. And they 95% of the time the conditions will be listed there. If not, the experiment will look like this. It'll look like, let me go back to this one, where they'll have the steps listed out explicitly, like step 1, step 2, step 3. Okay? Alright, let's move on to the next one. 27, I think. Yeah, Manvita.
For this one, it's like prior knowledge, so you need to know like the photosynthesis.
Okay, what is the equation for photosynthesis?
H2O plus CO2 yields C6H12O6 plus O2.
Good, so let me go to that right now. Alright, this is our equation for photosynthesis. And yeah, that's it. Okay, next one, 26. Who wants to first explain to me what they're doing in this experiment? Dumb it down for me. Varun, tell me what they're doing in this experiment.
They're like bending the ray with the filament or something.
Close. Who can help them out? So what they're doing here, they're shooting this cathode ray, which is just small particles of electrons. So they're shooting out millions of little electrons, and it's going through this little hole. So this is our experiment chamber where everything's going to happen. It's going to pass through this electric field. So this is like two magnets, all right? But except instead of a magnetic field, it's an electric current that's shooting downwards. Okay, so it's going to shoot through this. Then somehow it's being shifted upwards, and it's going to hit right here. And they're going to measure how high it goes. And that thing is like this. If it went completely straight, that would be 0. But since it went higher, it's some positive centimeters above. And that's all they're measuring. Okay? And whenever you want to see what they're varying, just look at the tables. They're varying direction, magnitude, V, which is electrical potential, and then L, which is the centimeters of something. Of this right here. The length of this. Okay? Alright. Let's see. It's 28. Who wants to do it? Ritik.
I got H. Because so in study 1, well, in study 1 there's a table. The table 1 it shows trial and the direction. Yeah, and show the direction of the electric current where it would go down or up, and it would give off the position of if it went down, then how high or low it would go. And so that was study 1 compared to study 2, which showed the location. So it showed the potential of electricity, and there's trials, and the Y was like the location of the end.
Good. Okay. The easiest way to do this one, notice how what's same in all of these. It's the Y. They always have a Y column, right? So what do you know our Y needs to be? That's our dry or our respondent variable, right? So what's our manipulating variable in this experiment? It's direction or magnitude. It's actually both in this case. In this case, what is it? What's our manipulated variable in this? V. Good. And in this one? L. All right. What is V? We go right here. It says electrical potential, comma V. Okay? Or if you're in physics, you should know V is equal to electrical potential. And that basically answers how study 1 and 2 differed, which is study 1 measured magnitude and direction, study 2 did electrical potential. 29, who wants to do it? Amitesh, actually Manvita.
Okay, so you underline study 2 and y 2.6, and then you underline the value of v. So then you go to study 2 and then you look at table 2, and the y equal to 2.6 is between 2.1 and 3.2. So the v has to be between 1 and 1.
Yeah. Let's go back and do that again. Okay, so study 2, 2.6. And then what'd you say, SB?
It has to be b because 2.6 is between 2.1 and 3.2, and the v has to be 1 and 1.
Good. So the right answer is B. All right, 30. Who wants to do that? Ritik. At Rashid Rohit.
So you underlined figure 2. You like serve as an illustration of the result. So I got a G.
Okay, how?
So you look at figure 2, and they give you like the scale and this like bright spot, and like that's kind of like at like 3.
Okay.
So you look at table 2, at trial 8, you look at the YCM, and then there it says like 3.2. So that's how I do that.
Okay, so that's 3.2. What's the easiest way, instead of looking at all of them for 3, what's another easier way to tell which trials we should even look for? Just look at, no, not the table, just look at the answer choices. All we need to look for is 1, 4, and 8. Okay, so let's check all of those. All right, 1, that's at negative 3.2, can't be that. 4, it's at 3, oh, 4 is at 3.2 also.
Yeah.
All right, and then 8. So what's our answer? It's 4 and 8.
J.
So J. Use the answer choices to guide you, okay? Notice how anything we do, we always use a question and the answer choices to tell us where our answer is, okay? That's the only way we do this. That's the quickest way to approach science. All right, 31. What do we, yeah, Ritik. So what's going to lead me to answer my choice, to find my answer?
To find the answer, you first need to look at study 1, so underline study 1.
Okay,
And direction for direction of E.
all right.
Likely point in study 2, and which direction did E most likely point in study 3? So you need to underline study 3.
Okay. In this question, these types of questions where they say based on the results of study 1, what I need to do is I need to look at trends that are in study 1 to help me answer the question. So explain how you did it.
Alright, so my answer was C, because in study 1, I looked at the direction, and whenever it was up, the y was always negative, and whenever the direction was down, the y would always be positive. So looking at study 2, all the results were always positive, which means that the direction was down, and in study 3, the results were always negative, which means that the direction was always up.
Perfect. All right, the answer is C. Does anyone have any questions on that? All right, 32. Who wants to do this? This one's a very hard one. Who can answer this? You guys work together. Reread this question. Try it out. I want you guys to figure this one out. Work with the people around you. Just try figuring it out. Figure this question out.
Did anyone get 5?
I didn't even get this.
Oh.
But
Because I picked 1 at first, but I was like, well, that's not right, because it shows that they cannot be reopened, and they can change the V and E, and V does not. Wait, V does not consist of the direction, does it?
V doesn't change.
No, you can change the V and E.
But the V and E
It
are
says they don't
controlled.
change.
Yeah, no, they don't change. So that means it has to be more than one because in study 1, there's 2 different directions. So 2, 3, 4, but
Wait.
Study one. Study two.
I doubt.
Five.
Wait, wait,
Actually,
Study three, wait,
I think
wait,
it's 5.
I think it's 5.
Yeah. Wait.
Alright,
Wait,
so
how'd you get that?
so the direction is 1.
Yeah.
The other direction is 2.
Do you guys have an answer for this?
I think G.
Why?
Well, so the table in table 1, it says you can change V and E from the outside, but that's not in direction. So there's gonna be one direction that goes up, one direction that goes down for study 1. For study 2, since it's all positive, that means it's only going in one direction, which is down. And for study 3, all the results are negative, so it goes up. So that's only 4.
Okay. You're on the right track. Does anyone else have a better explanation to that? Okay, let's read the question again. Once a CRT is sealed, it cannot be reopened. Okay. However, because both V and E are controlled from the outside, a CRT can be used repeatedly. Okay. So for V and E, we can use the CRT repeatedly under varying conditions. Based on the description of studies 1 to 3, what is the minimum number of different CRTs that the students required to complete the 3 studies? Okay, so let's start from the first one. For V and E, we can manipulate from the outside. So what's being manipulated? What are we doing here? We're changing magnitude, which is what? E. Okay, so for this one, we're controlling the CRT from the outside. For here, what's being manipulated? V again, so we're controlling it from the outside. Here, what's being manipulated? L. So we need to open up the CRT to manipulate this one. So what is this CRT? Just think of this as a light bulb. Like one of those lights right up there. It looks almost exactly like that. You have to crack open the glass to actually get inside it. So if I start out with one CRT in trial 1, I can reuse that in trial 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then I can reuse that one more time in trial 12. However, to get from trial 12 to 13, I need a new CRT. So I need 2, 3, 4, and 5. That gets me 5 CRTs. Does that make sense to everyone?
Yeah.
Vern, can you explain that question all back to us, please? What's that?
I can't.
Why not?
Pay attention.
All right, who can help him out? Venkat, can you explain this question back to us?
Yeah.
All right.
Since in study 1, E's being changed, and in study 2, B's being changed, you only need one because those two can be manipulated. But in study 3, you can use the same thing for trial 12, but you need to get another CRT for 13 or 14 or 15 or 16.
Good. All right, Vern, you get it now?
Yeah.
Okay, good. All right, 33. Vern, can you explain this one to us? All right, let's break this question apart, Vern. Suppose that students had performed a trial in which the cathode ray traveled all the way from the filament to the screen in a straight path, striking the screen at y equals 0. Based on the results of study 1 and study 2, which of the statements about V and E would have been true? Okay, so we want to get y equals 0. All right, so based on V and E, how do I get y equals 0? Well, right here, look. Magnitude of 1 times 10 to the 4th gives me negative 3.2 versus 1 to 10 to the 4th gives me positive 3.2. So I want my magnitude to be 0 because notice how all of these are the exact opposites of each other. If I want my y to be 0, I need my magnitude to be 0. However, notice how this is getting smaller as my v is increasing. So I want a super high v to get as close to 0 as possible. So I want a high v, but my e to be 0. So I need my v to be a non-zero, but my magnitude of e to be a 0. So the answer is B. Everyone get that?
Yeah.
All right, 34. Okay, this one's a hard one as well. You'll learn this in AP Physics as well. Whenever you have a parallel plate for an electrical field, you have all these lines right here. You have the electrical field going downwards. Electrical fields always go from positive to negative. I don't know why I'm writing E, but it always goes from positive to negative. And this is your electrical field. Okay? So, in this picture right here, this is an electrical field, since the arrows are going downwards, it's going from positive to negative. Okay? You do not need that prior knowledge to answer this question. This would be the positive end of the plate. This would be the negative end of the plate. You don't need that prior knowledge to answer this question. How you do it is, in a CRT, E is generated by building up equal and opposite electrical charges on the two conducting plates. Because the cathode rays are negatively charged, if E is directed downwards, as shown in figure 1, which conducting plate is more likely negatively charged? So, the only important thing they said in this entire paragraph they had told us was, the cathode ray is negative. So, if this cathode ray is negative, what is this? Are they shooting out protons or electrons? Electrons, because they're negatively charged. So if these electrons pass through here and are starting to curve upwards, what is this saying? It's opposites attract, right? So if this is getting closer to the top, what is this most likely? Positive. Negative.
Oh.
When I have two negative protons, what do they do? Yeah. So since the cathode ray itself is negative, and it's getting close to the top as it goes through here, notice how it's slanting upwards? This must be positive. And it must be getting repelled by the bottom, which is negative. And the question is asking, which one is most likely negative charge? So is it the top plate or bottom? Bottom. Okay, so that gets rid of G and F. How do I differentiate between H and J? Because charges of like signs are attracted? Is that true? No, it's J.
J.
Alright, let's go on. 35, who wants to do it? This one's easy, it's D. According to figure 2, underline figure 2, what is the order of gas samples from shortest to longest for n equals 15? So I go to figure 2, I'm going to go to n equals 15 right here, and I'm going to look shortest to longest. So I'm just going to do XE, KR, AR, and then NE in that order, which would be D. Alright, next one, who wants to do it? I'm Tesh.
I didn't get it. I can do it.
Alright, try it out.
So you underline figure 2.
Did everyone finish this last passage?
No.
How many of you guys didn't? Raise your hand if you did not finish it. Okay, take another 2 minutes and finish this one. Don't change anything on your scan. Oh, you don't have it actually. Alright, finish this section up.
curious.
All right, let's go over this one. Who can do 36? Vamos go.
You underline figure 2, doubling NE 6 times the 10 thing, and then 12 times 10 to the 23rd. And then you look at figure 2, and for 6, for 6, NE is at 1600. So if you want that to be at 12, it's 800, and that divides by 2, so it's G.
Yes, good. All right, 37. Ruin 37. Well, how'd you get 2? Nope. Who else? Rohit. 27, or, yep, 37.
I don't really know.
Okay. Appreciate 37.
But C.
How'd you get C?
If you look at KR and 293 is already given in the figure 1. So instead of n equals 6 times 10, 23, and then but it shows that it's 25. That's think how much greater would the 51 be. So now if you look at 0 to 25, it goes up 300. So you can guess that 25 to 50 will also go up 300. So it will be
Good.
600
What do we call this type of growth? Nope.
linear.
This is not even close to being exponential. Okay. This is linear. All right. That is exactly it. So what you do is you just extend this line right to KR, and you can see from 0 to 25 it goes up 300. So from 25 to 50 it should go up another 300, which is basically multiplying it by 2, which is C. All right, 38. Who wants to do it? Ritik.
So you underline figure 1, XE and AR compared. So how I got G, and how I got that was, so I looked at the XE in figure 1. I looked at XE and AR, and what do you call the side? That's the y-axis.
The y-axis?
Yeah.
What do you mean what I call the side?
No, the sign.
The sign. Oh, the y? Lambda.
What?
What do I call this letter? Lambda.
Lambda?
Lambda, yep.
Alright, so look at the lambda and how much longer AR is than XE. So XE is like around, yeah, so it's around
You always round up and guesstimate on this, okay?
alright, so it's 200, around up to 200,
Mhm.
and AR is up to oh wait, it's J.
Yes. All you do is just do 4 minus 2, you get 2, which should be 200. Alright. And last one, let's do it. Appreciate it.
Wait, which one?
Oh wait, 39. I forgot we have two more.
I got an 8.
Okay, and how?
If you look at figure 1, the XE items. Wait,
Do you really need a figure for this one though?
no,
This is a prior knowledge question.
yeah. So basically it says that, if there's a smaller distance, that means it'll collide more,
Mm-hmm.
which is why it would be 5L. Because at 5L it's less distance than 25L. So yeah, the occlusion frequency would be more higher at 5L.
Good.
So,
How you do this is think of gas expanding in the entire basement versus gas expanding in like a water bottle. Gas would more likely bounce off the walls of a water bottle than in this entire basement because there's more volume. Okay, so that's why we want a smaller volume, so that eliminates C and D. And then how we differentiate between these two is it would be a shorter distance, not a longer distance. Okay? And the right answer should be A. Alright, 40. Who wants to do it? Venkat, 40.
I can get through it, but I'll try.
Alright, try it. Want to solve them out?
Is it?
So how do we do this? It says for a particular sample of radon gas in a 25-liter container at 293 Kelvin, lambda is approximately 320 nanometers. If D for Rn is 0.24, then based on table 1 and figure 2, how many radon atoms are most likely in this sample? So I'm going to go look at table 1, and I see 0.24 is higher than xenon. Okay, so my Rn needs to be somewhere here. Rn would be right here, and it's greater than xenon. So I'm going to go back to figure 2 now. If it's greater than xenon, look at this table. It goes Ne, Ar, Kr. So, and this table goes Ne, Ar, Kr. So isn't this following the exact same trend as these letters? So where should my Rn be? Should it be down here or above neon?
down.
It should be somewhere right here. So the curve would look something like that. And that would eventually be less than 6. Okay. That's it for now. The answer should be less than 6F. Okay, we're going to go on to English now. Take out the packet from last week, from a couple weeks ago, and I'll give you a copy. No. Okay, this one should be 71E English. So take that out, everyone who has it, and I'm going to get you a copy. Give me a sec. Okay, you don't have it? You got to bring all your papers, anything except diagnostic tests you have to bring. I don't have another copy.
Can I just share with?
No. Give me a sec. Let me see what I can do for you. Guys, clean up your shit when you guys leave, okay? I don't want to pick it up. Alright, Venkat, sorry man, I only have one copy. So, what you're going to do is just look at it off the laptop.
Are we just finished with it?
Yes. 71E. It should say greeting of the winner at the top. And then you have to finish up. We're only going to do the last half of it, so you got to finish up the first half for homework and send me a picture tomorrow, okay? Alright, let's pass these Scantrons out. Who's 9522? in here. Okay, 8321. That's not yours. It's not here. Who is 78031? Right. 6773. Okay. Two 23851 and 24354. I'll get you a blank one. Thanks. Start on question 46, or whichever one we start on. Okay, so let's go. Let's start